The following teacher development program is brought to you by the MultiChoice Africa Foundation.
Lebo?
Oh, Tandy.
Shouldn't you be getting ready for the first dinner in your new kitchen? Hey, you've bragged about the hot date you've been trying to impress. Has she pulled out?
Oh, me getting a date is not a problem. My problem is getting enough tiles to finish my floor. This is my 5th trip today. You know, I could use some help.
Say, please, and yes, Tandy, I'll listen to every word you say.
Please. Yes, Tandy. I will do everything you say.
Okay.
Great. Hop in. How come do I keep on getting it wrong? I've had 2 little tiles every single trip.
Look, you should have done a few things before you went to the shop, like measuring the floor and working out the amount of tiles. I mean, these are the basic steps, you know.
Yeah, well, not me. You are the math expert. I'm a PE teacher. Physical education. I coach sports, not abstract theories.
Lebogang, whatever you are, everyone needs math literacy skills. It teaches you the logic and means to apply math to situations in everyday life, whatever your persuasion.
Wow, you sounded a bit like a politician. Scouting for math literacy votes. Getting to the podium now.
Suga wena, leave politics out of this. My word, what a mess!
I think I should phone and postpone my date, eh?
Really don't care about you and the woman in your life, hey? But before you call her, let's see how far we can get. Let's start by clearing up this mess.
Okay, Tandy. Let's see your math literacy in action.
So, where's your measuring tape? Obviously, the first thing we have to do is measure the floor. So, where is it?
I know exactly where it is.
You do?
Okay, give me 2 tiles then. Give me another 2.
Have you decided which way you're going to lay the tiles? This way or that way?
Does it make a difference?
Of course it makes a difference. We're going to be working in rows.
I prefer it like this.
Yeah, I think that's nice. Besides, I read somewhere that it creates an illusion of more space.
Oh, well, I wouldn't know that. You are the artistic one.
Hey, we'd better get a move on. We still have to work out how many tiles we need in a row. Get up! Did you measure the tile? Why not? Oh, never mind. Let's do that now. Let's measure the width and the length of it.
The width, 20, and the length, 30.
Great. And then what we do is you take the longest side of the tile and divide it into the length of the floor, because this is how they're going to sit, right?
Oh, wait. Let's make sure I've got it. You take the length of the tile into the length of the floor.
That's right. Now, let's see how much we get.
2.5 divided by 30, 0.08. But that means I need less than a tile to finish the whole kitchen. It can't be right. Let me do it the other way around.
That's not the problem, dummy. You must convert your measuring units. You can't divide centimeters into meters.
Ah, of course. Right. Aha. Okay. It's 8.333 tiles.
Yes! 8 1/3 tiles. But you mustn't become a slave to the calculator. You must think about what you're doing. Okay, if you have 8.3 tiles, it means you'll need tiles for 9 rows, because the last one is going to be cut, obviously.
Yeah, I've got it.
Now, let's see if you can calculate how many tiles we'll need across in rows. I'm sure you can calculate that one.
One tile. Okay, I'm going to take the width of the floor, which is 1 3/4 meters, divided by 20 centimeters, the width of the tile. All right, now I won't do the same mistake again. I'll make sure that I convert everything into centimeters. 175 divided by 20 equals to 8.75. But how? No, wait, man. I can't buy half a tile. Maybe I need... Oh, yeah. I need 9 rows of tiles.
Great! You've got the hang of math literacy. Now, how many tiles do we need altogether?
Okay. 9 times 9 is equal to 81. 81 tiles. Cool! Tile shop, here we come again for the last time. That's it.
Hey! Not so fast. How many tiles are there in each of those boxes?
5.
And how many boxes do you already have?
10. I know, I carried it each and every one of them.
Well, I'm happy to announce we have the final answer. We need 7 more boxes. That will give you extra tiles just in case any of the others break.
Sure. Okay, let's go. But I'm not leaving you behind. You are coming with me. What's... You know, this math literacy thing is all very interesting and practical and so on. But how do you teach it in a classroom?
You know my friend Mrs. Naves? She told me that she taught the very thing in her math literacy class. Yeah. So you've got a lot of work to do, hey? As a math literacy teacher, Dolly Naves knows that one of the most important math skills you need for life is measurement.
So today we are going to learn about measuring. Our lesson today is going to be based on tiling and how do we measure, how do we get the area of the surface that we have to measure.
She gets the learners to measure different rectangular objects to refresh their measuring skills. Dolly notices that some of the learners are confused by the different units. They've measured the classroom to be 690 meters long.
She steps in to explain.
You see, we have joined 4 rulers together to make a meter. This is 1 meter. So 690 meters is a very big number. Maybe you did not use meters, you have used a different unit.
The learners know how to do textbook problems calculating the area of a rectangle. But when it comes to doing it for real, it's not that easy.
621.6.
Dolly emphasizes that when you multiply length and width, they have to use the same measuring units. You can't simply multiply 100 centimeters by 1 meter. The learners are making tiles out of cardboard. Dolly gets them to cut out square tiles. One tile has sides that are 10 centimeters long and the other tile has sides that are 100 millimeters long. The learners should realize once they convert the sides in millimeters to centimeters that these 2 tiles are the same size. The learners write the length of each side on their tile. This makes it easy to calculate the area of each tile. They also make a big tile with sides of 20 centimeters long. Dolly makes sure the learners calculate the area of each square correctly before they go on to the next step.
And the breadth is also 20 centimeters. It will be the area.
200 centimeters square.
Is it 200? 400. It is 20 times 20. So the shortest...
The learners draw a grid on the tile with the 10 centimeter sides so they can see for themselves that it's 100 square centimeters. It's obvious that the tile with the 10 centimeter sides is equal in size to the tile with the 100 millimeter sides. Dolly planned it this way so that the learners can use this as a basis for an equation that can be used to establish the relationship between centimeter square and millimeter square.
Equals to 10,000 millimeters squared. Here we're going to cancel 2 zeros, and what we do on the right we also do on the left. Also cancel 2 zeros, and then we're going to be left with 1 centimeter squared, which equals to 100 millimeters squared.
Math literacy is about using maths in the real world, but that doesn't mean we should just memorize a whole lot of useful equations. We also need to think about how we got to these equations.
Centimeter squared. It's equals to 1 millimeter square.
Now that the learners know how to convert from centimeter square to millimeter square and vice versa, it's time to learn how to convert between centimeter square and meter square. Dolly has prepared a 1 meter by 1 meter piece of cardboard, which learners have to pretend is a tabletop for a kitchen table that has to be tiled.
1 square meter.
The learners place their tiles so there is no space between them. They know the area of each tile in square centimeters. If they add up all the areas, they should get how many square centimeters fit into a square meter.
Can you count the small ones?
They are 36, ma'am.
They are 36.
3,600.
We get 3,600 square meters.
16.
So if we have 16 big tiles, 1 tile is equals to how many square centimeters?
400 centimeters.
400 centimeters squared. So you are going to multiply 400 by 16.
Maths literacy today was interesting because we learned many things like tiling, and I learned that you need maths to do tiling.
What will be the unit?
By getting the learners to do an exercise with real shapes and areas, Dolly has laid a solid foundation for learners to understand conceptually how to convert square units of measurement.
You know, know, I wouldn't mind seeing a professional tiler in action. You've got measurements, you've got tiles, and so on. But I bet you there's more to tiling with this math literacy thing.
Well, I'll tell you one thing. They don't measure tiles the way we did. They simply work with areas. And then they know exactly how many tiles go into 1 square meter. Then they add 10% to the end tiles, the ones that will have to be cut.
Now tell me, it would have saved us lots of trouble. How do you know this?
You know us math literacy people. We're considerably smart. Besides, you got to learn about measuring and converting units. Something you'll never forget. To get back to your question, the other day I met a paving expert. He told me a couple of things.
John Kok designs and lays paving for a living. John shared some maths tips he uses to calculate how many bricks he needs to pave a triangular area.
In measuring the surface area of a triangle, there are basically 2 types of triangles. The first one would be a triangle with a 90-degree corner. When one measures a triangle with a 90-degree angle, you take the upright times the base divided by 2. But when we look at the triangle like we've got on my left here, without the 90-degree angle, you would take the base times the perpendicular height divided by 2, which would typically give you the surface area. The base was measured as 4.1 meters, and the perpendicular height was measured as 3.4 meters. What we then do is take 4.1, multiply it by 3.4, and divide it by 2, which would typically give the answer of 6.97 meters. Because of the extra cutting we would have here, we would roughly add about 5% when calculating the brick quantity that's needed.
Once John has calculated the area in square meters, it's easy to calculate how many bricks he needs. The paving catalogue will tell him how many of each type of brick fit into a square meter. Square meters are the unit for any shape of area. A 12 meter by 1 meter rectangle is 12 square meters. So is a triangle with a base of 4 meters and height of 6 meters. So is a circle with a radius of 1.95 meters. If you know the formula for calculating the area, your answer will always be in a square unit of measurement, like square meters, square centimeters, or square kilometers.
Maths is without a doubt an integral part of our job. I do not think we can do anything without math calculations. From simple calculations as we looked at on calculating surface area, to calculating the materials and the quantity of bricks that's available, to calculating the other materials that would be needed.
Wow, Lebo, this looks fabulous. Using math literacy is fun and practical, don't you think?
Tell me, why didn't you take the space between the tiles into consideration?
Well, it's so small, it doesn't make much of a difference.
I know so much about this stuff. I could become a math literacy teacher. Tell me, what does it take?
Well, you need a teacher certificate. A keen interest would be a plus. You'll do a course and you'll get in-service training.
Yeah. Tandy.
What?
What are we going to lay the tiles with?
Man, we don't have tile cement.
Tile shop.